Okay, we're going to pick it up here. This is getting into I do believe this was Unit 4, because we're going to be using our note card here in a minute. Sum and difference identities. Remember, you had to memorize the ones for sine and cosine and tangent, and after that we used the note card for doubles and halves. So find the exact value using a sum or a difference identity. So we need to either add or subtract to 105. So it's basically just whichever one clicks with your brain as to what you need to do. If you're going to go to 105, I would suggest 60 plus 45. So we have 60 plus 45. So remember your sine sum rule. It's sine, cosine, cosine, sine, cosine, cosine, sine, 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 and that's both rules all together. So we have sine of the first one and cosine of the second one. We're going to keep the same SIGN, and then we're going to do sine, cosine, cosine, sine. So cosine, keep the angles in the same order. It's your trig functions that change. Okay, now this is where it gets interesting, because remember, you want an exact value, so we're needing square roots. We don't need decimals. So you need to think about, okay, what does a 60-degree triangle look like, and what does a 45-degree triangle look like? So 60 degrees, we have opposite 60 is square root of 3, adjacent is 1, hypotenuse is 2. For 45, we've got 1, 1, square root of 2. So we need to evaluate those, and let's put our values into your identity. Sine of 60 degrees is opposite over hypotenuse, square root of 3 over 2. And if you just want to stay with the same triangle, I don't blame you. Go ahead and do your cosine of 60, which is adjacent over hypotenuse. Now swap and go to your 45. Hopefully we've got it stuck in your head what sine and cosine of 45 is, because 1 over square root of 2 must be rationalized to square root of 2 over 2. Alright, so let's go ahead and multiply. Remember, insides go with insides, outsides go with outsides. So that's going to be square root of 6 over 2 plus square root of 2. Oops, excuse me, that's not 2. Square root of 6 over 4. And square root of 2 over 4. And you could put them together for one nice little fraction. Now, what we did run into before, remember, some of the test generators put this in an interesting format. So what they do is they actually factored out the square root of 2 and left you with square root of 3 for the first term and a 1 for the second, but everything was still over the 4. So don't get thrown off if they put it in a strange format. Okay? Okay, cosine of 285. Let's see here. Why don't we use 240 and 45? So cosine 240, because we can do that. Remember, you can do special right triangles and you can figure out 240. So even though it's a little large, you can still work this out. So the cosine rule is cosine, cosine, sine, sine, sine. But that first sign is SIGN. So we got to do cosine of the first angle, cosine of the second angle. We are going to reverse this sign. And then we're going to do sine of the first and sine of the second. So we need to draw reference angles for 240 and for 45. Well, the 45 should be fresh on your mind because we just did it. So that right there shouldn't be a problem at all. This should be easy, square root of 2 over 2. We just did it. 240 is going to be in third quadrant. The difference between 180 and 240 is 60. So opposite the 60 is going to be square root of 3. Then we have the adjacent side is 1, hypotenuse is 2, but we went left and we went down, so we need to pick up some negatives. Cosine of that angle is going to be adjacent over hypotenuse, and sine of that angle is going to be opposite over hypotenuse. You just want to multiply your terms. You've got a negative square root of 2 over 4. Now, be careful over here. Don't lose your SIGNs. Okay, we have a negative here. We have a negative there. That needs to be a plus. Okay, so that's going to be square root of 6 over 4, and you can smash it together. Look, don't get bothered if they have it listed like that, or if they have it listed with square root of 6 minus square root of 2 over 4. It's the same thing. Just make sure that the appropriate term has the appropriate sign. So negative square root of 2 needs to be negative. The square root of 6 needs to be positive. But if it's backwards, don't fret about it. Okay, tangent of 195, we're going to use 150 and 45. So tangent of 150 and 45. All right? And look, if you come up with some angles that also either add or subtract to what you need, feel free to use them. As long as you can draw them out and get exact values, it's great. These are just the ones that I thought of. Now you gotta remember your tangent formula. Tangent was tangent of the first, same sign, tangent of the second, all over 1 minus, or excuse me, 1 with the opposite sign, and then the product. Tangent of the first, tangent of the second. So we could be ending up with a complex fraction here, but yeah, that shouldn't bother you. So let's prep it, and then let's draw some triangles. That tangent of 45, that is a beautiful thing, because tangent of 45 is 1. Those are great. Now the tangent of the 150, let's see. So 150 gives us a reference angle of 30. Opposite the 30 is a 1. Adjacent, square root of 3. Hypotenuse is 2. We went left, so we need to pick up a negative. All right, tangent of that angle, ew. Opposite over adjacent is going to be 1 over the negative square root of 3. You've got to rationalize. Negative square root of 3 over 3. So yes, we have a hot mess. But just go slow and you'll be just fine. That's going to be negative square root of 3 over 3 plus 1 over, and then 1 minus, oops, excuse me, negative and negative makes positive. Square root of 3 over 3. Well, I don't need a complex fraction. I want to get rid of that. All of my baby fractions have a 3, so I'm going to multiply through by 3 over 3 and clear it of complex fractions. So 3 times this first one, the 3 is reduced because remember that's over 1. So that's going to be a negative square root of 3. Let's scoot this up some. All right, and then I'm going to do 3 times the back term, which is just 3. And then I've got to distribute this one. 3. And then that one is going to cancel out the denominators and give me that. That would be great, but you're not allowed to have square roots in the bottom of a fraction, and you have a binomial. So again, you've got to rationalize. When you rationalize, you've got to use your conjugate. So if we're trying to get rid of this square root down here, use the same binomial, opposite sign. Okay. Now if you want to, you could take this one right here, turn him around where your binomial is a perfect match, because all that is 3 minus square root of 3. And then you can do your square the first, twice product, square the last. It's just kind of up to you. But remember, the magic's going to happen in the bottom when you do your full. Your middle terms are going to go out because they're conjugates. So you're going to have the first one squared, and it's always and forever going to be minus the back one squared. Well, when you square the square root of 3, you just get 3. Now, I'm going to go the fast way on the top. If you need to slow it down and distribute slowly, no problem, but I'm going to zoom through it. It's the same binomial, so we're going to square the first. We're going to do twice the product, so if I multiply them together, I get negative 3 square root of 3. So that's going to be negative 6 square root of 3 when I double it. And then it's going to square the last, is going to be positive 3. Clean that up. 9 and 3 go together. That's 12 minus 6 square root of 3 over 6. Now, if you'll notice, all of these terms, you have 3 terms. You have 1, 2, 3. Every term can reduce by 6. So you need to reduce all 3 terms by 6. And remember, inside numbers don't play. So this guy does not get to play. It's only these outside numbers. Divide them all by 6, and you're going to get 2 minus square root of 3. There's a 1 in the bottom. You don't have to write it. Okay, so we need 2 minus square root of 3. All right. Use the identity for cosine of a difference to write the expression as a single function of x. Okay, so the cosine rule, remember, was cosine, cosine, sine, sine, sine. So we're going to do cosine of the first one, cosine of the second one. And since this is minus, we have to change that to a plus. And then we're going to have cosine, it'll be sine. My bad. Sine and sine. So here we go. Cosine, cosine, sine, sine, sine. That's the way it works. Now 270, that is unit circle. Unit circle down here, that ordered pair is 0 and negative 1. The first value is cosine, the second value is sine. So we're going to bring down this cosine. But cosine of 270 happens to be 0. So we're going to put a 0 there. We've got sine of x. And sine of 270 is this -1. So this 0 gives us a nice favor and cancels out that term. And when you multiply these two, you just get negative sine x. So it worked out pretty well. All right, let's see if we can get another one squeezed in here. Oh, good. These are the ones that shrink. You have to realize which one of the rules it is. We have cosine, cosine, and sine, sine. Well, that fits cosine, cosine, sine, sine, sine. That means we've got to change this booger. So that's going to be the cosine rule. First one, we're going to change that, and then the second one. So what this is really asking us for is cosine of 180 degrees. 180 degrees, unit circle, ordered pair over here is -1, 0. Cosine is the first one, so -1. All right, when you look at this one, you got sine, cosine, cosine, sine. That's your sine rule. So it's going to be sine, and then we have the first one. Remember, your operation stays the same. And you have your second angle there. So we're going to actually sum those up, and we get 135. That's something that we can draw a reference angle for. That's going to be in the second quadrant. You have a reference angle of 45. Okay, opposite, adjacent, hypotenuse. We went left, so we need to pick up a negative, but it doesn't really matter. Sine is opposite over hypotenuse. So 1 over square root of 2, you got to fix that. Square root of 2 over 2 after you rationalize. Okay, when you see this one, hopefully tangent dawns on you. But you got to remember how the tangent rule is structured. It's always with this is what was in the original. So you've got 155, and we're going to have minus 35, okay? So you actually have to work that out. 155 minus 35 is going to be 120. So we need to sketch 120. We're in second quadrant again, but 120 gives us a reference angle of 60. Opposite the 60 is going to be square root of 3. Adjacent is 1. Hypotenuse is 2. We went left, so we need to pick up a negative. Tangent of 120 is going to be opposite over hypotenuse, so that's going to be square root of 3 over a -1, which is just negative square root of 3. Okay, well, let's see if we can squeeze another one in. We've only got 1 minute left, so let's wind it up right here, and then we'll start again on the next video, okay?